Good morning all of you. Welcome to the video class of software engineering. This is your third video lecture. In previous session I have discussed about software development life cycle, and in this session I will discuss about classical waterfall model. So let's start our topic. The classical waterfall model was the first model to be introduced. It is also referred to as linear sequential lifecycle model. In a waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping in the phase. Means in waterfall model, first a phase is completed, then the next phase will start, and we cannot go back to the previous phase. And this is also the most important drawback of waterfall model that I will discuss later on. The phases of classical waterfall model. First phase is feasibility study, then requirement analysis and specification, design, coding and unit testing, integration and system testing, and maintenance. Classical waterfall model, as the name suggests, it look like waterfall. Each phase come downwards and we cannot go back to up. We cannot go back to the previous phase. This is the effort chart for each phase. The phase between feasibility study and testing is known as development phase, and the maintenance phase required the maximum effort. The ratio is 40:60, means 40% effort is required for development phase and 60% effort is required for maintenance phase. In the development phase, the maximum effort is consumed by testing phase. The first phase is feasibility study. The main aim of feasibility study is to determine whether the product is financially and technically feasible or not. First, the developer roughly understands what the customer wants. Different data which would be input to the system, processing needed to that data, and what are the output produced by the system. Various constraints on the behavior of the system. Means in this phase, the developer understands the customer needs and roughly identify the input data, the processing to the data, and the output of the system. Activity during feasibility study. The developer work out an overall understanding of the problem, formulate different solution strategy, examine alternative solution strategy in terms of resource required, cost of development, and development time. Means the developer overall understand the problem and find out the different solution strategy. Developer perform cost benefit analysis to determine which solution is the best. It may determine that none of the solution is feasible due to high cost, resource constraint and technical reasons. If the product is feasible, then it will go to next phase. Requirement analysis and specification. This is the most important phase. Aim of this phase is to understand the exact requirement of customer and document them properly. It consists of two distinct activities: requirement gathering and analysis, requirement specification. First, the developer gather the requirement from the customer and analyze them, and then it specify in a proper way. First, requirement gathering. Gathering relevant data. Usually data were collected from the end user through interviews and discussion. For example, for a business accounting software, interviews all the accountant of the organization to find out their requirements. In this phase, developer go to the end user and customer and gather the information. Requirement analysis. The data initially collected from the user usually contains several contradictions and ambiguity, because each user has only a partial and incomplete view of the system. And the ambiguity and contradiction must be identified in this stage and resolved by discussion with the customer. And then the requirements are organized into a software requirement specification document that is known as SRS document. Engineers doing requirement analysis and specification are designated as analysts. When the SRS document is completed, then it will go to the next phase. The next phase is design. In technical terms, during design phase, software architecture is derived from the SRS document. There are two design approach: traditional approach and object-oriented approach. First, come to traditional approach. Traditional approach consists of two activities: structured analysis and structured design. Structured analysis activity. The developer identify all the functions to be performed, identify data flow among the functions, decompose each function recursively into sub-function, identify data flow among the sub-function as well. Means in this phase, the developer from the SRS document find out the main functions and identify the data flow from function to function and decompose the each function to sub-function. Structured analysis. It carried out using data flow diagram, means DFD. After structured analysis carried out, structured design. There are two types of structured design: architectural design or high level design, detailed design or low level design. Structure design, high level design, decompose the system into module, represent invocation relationship among the module. In high level design, from the DFD, the developer designed different module and the relationship between the modules. Then detailed design. In detailed design, different module design in greater detail. Data structure and algorithm for each module are designed. Next, object-oriented design. In object-oriented design, first the developer identify various objects occurring in the problem. Identify the relationship among the object. For example, the object in a payroll software may be employee, manager, payroll register, department, etc. Object structure. Further refined to obtain the detailed design. Object-oriented design has several advantages. Lower development effort, lower development time, and better maintainability. Coding and unit testing. In this phase, programmer translates software design into source code. During the implementation phase, each module of the design is coded. Each module is unit tested independently as a standalone unit and debugged. Each module is documented. Means in this phase, the programmer write program for each module as per the design document, and each module is tested as a standalone unit and document them properly. The purpose of unit testing is to test individual modules work correctly. The end product of implementation phase is a set of program modules that have been tested individually. After testing each unit, the next phase is integration and system testing. Different modules are integrated in a planned manner. Modules are almost never integrated in one shot. Normally, integration is carried out through a number of steps. During each integration step, the partial integrated system is tested. Means after unit testing, each module are integrated in a planned manner, and the partially integrated system is also tested. After all the modules have been successfully integrated and tested, system testing is carried out. Goal of system testing: ensure that the developed system functions according to its requirement as specified in the SRS document. Means in the system testing phase, the fully developed product is checked by the testing team as it works as per the requirement specified in the SRS document. Then the next phase is maintenance. Maintenance of any software product required more effort than the effort to develop a product itself. The development effort to maintenance effort is typically 40:60. There are three types of maintenance. First one is corrective maintenance. Corrective maintenance correct the error which were not discovered during the product development phase. Means when the fully developed product work on the customer environment, if there come any new error that is fixed by the developer team, it known as corrective maintenance. Then the second one is perfective maintenance. Improve implementation of the system, enhance functionality of the system. If the customer wants any new function in the system, that is taken care by the developer team and it known as perfective maintenance. Then the last one is adaptive maintenance. Port the software to a new environment, for example to a new computer or to a new operating system. This is all about the phases of waterfall model. Then advantage and disadvantage of waterfall model. Advantage: before the next phase of development, each phase must be completed. Means in waterfall model, after completing one phase, then we can start another new phase. Disadvantage: error can be fixed only during the phase. Means the error can be rectified in the current phase, because later on we cannot go back to the previous phase. Advantage: it's suited for smaller projects where requirements are well defined, and it is not suited for complex project where requirement changes frequently. They should perform quality assurance tests, means verification and validation, before completing each phase. And disadvantage is that testing period come quite late in the development process. Elaborate documentation is done at every phase of the software development life cycle. Means in waterfall model, elaborate documentation is required. So the disadvantage is that documentation occupy a lot of time of developer and tester. Any changes in software is made during the process of the development. And disadvantage is that small changes or error that arise in the completed software may causes a lot of problem. Means if any error occur in during that phase can be rectified, but after completing the software, if any error or small changes required more effort or it create a lot of problem. These are the advantage and disadvantage of waterfall model. So this is all about the classical waterfall model. Thank you.